Alrighty, good morning or good afternoon, ladies and gentlemen. Today I'm going to show you how to do something called a multi-step trigonometry problem. So this is in our assignment. This will cover the last 4 or 5 problems where we see combined triangles, and it'll be leading into 3-dimensional trig problems. So I have a couple of examples here that I'd like to go over with you. A couple things to keep in mind, or just as a reminder, we have our toolbox. So we have sine, cos, and tan, so I'm just going to write SOHCAHTOA here. So to remember, sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. I also have my a squared plus b squared equals, I'll say, hypotenuse squared. And I want to keep in mind these work only for right triangles. So I'm looking for a triangle with a 90-degree angle at some point. So we're going to start with number 1. And right away, these want us to find this value here of x. So really what this problem here is saying is I have 2 triangles. I'm going to split them apart for a second. I have this one, that's 45. And then I have another right triangle that is 45 degrees and then 10. Now it wants me to solve for x. And one of the things I want you to keep in mind is that to solve these right triangle problems, we usually need one of 2 things. So we either need two sides. If we have 2 sides, we can find an angle, or we can find a third side, or we need one side and one angle on a triangle. If I don't have that, I can't solve for it. So currently it's asking me to find this side length right here. But given the triangle that I have one angle, I have my missing side, but I don't know the other 2 lengths. So I don't have enough information to solve currently. So step number 1, look for a shared side from 2 right triangles. So what I mean by that is I have 2 triangles here. I'll call this one triangle A and I'll call this one triangle B. And I'm looking for where they share a side. So triangle A is in black, this right here, and then in red triangle B is this one here. And I see that they share a common side right here. So I'm going to call this side y. So now I need to solve for my y, because once I figure out what y is, I will now have an angle and I'll have a side length on triangle A that I can solve for. So this is y and this is y. So I'll say solve for y using triangle B. So what we really have to solve is this to start. So my angle is here, my right angle is right here. So 10 is my hypotenuse, and then going across y is my opposite. So I'm looking for opposite and hypotenuse, so going over to SOHCAHTOA, I want to start by using my sine. So to write this down, I'll say the sine of 45 is equal to opposite, so I'm going to change that to y, or I'll start with opposite over hypotenuse, making this sine of 45 is equal to, the opposite is my y, and then hypotenuse is 10. So I'm going to go through steps to solve for y. So cross multiply this up, so I have 10 times the sine of 45 equals y. And then plugging that all into my calculator, I should get a value of y is equal to 7.07, and it'll continue going, but I've rounded to 2 decimal places. So now, because this is a shared side, my second triangle, so triangle A, now looks like I have a 45-degree angle, I have 7.07 here, and I have x up here. So now I can solve for x. One of the things to notice, though, is if this side is my y, one word of caution, sorry, this is a little bit chunky, y is not the opposite on triangle A. In this case, 7.07 is the hypotenuse. Because if I notice, my right angle triangle, or my right angle is here, so across from it is my hypotenuse, and my x is my adjacent side. So in this case, I'm going to use, I have adjacent and hypotenuse, I'm going to use cosine of 45 is equal to adjacent, so x over 7.07. So cross multiplying, I can get x is equal to 7.07 times cos of 45, and this gives me a final value of x is equal to 5. There's no units in this problem, so I can just leave it as 5. So notice the steps here. I looked for a shared side. Once I found that, I used it to solve for that side. With the triangle, I had more information, so in this case it was triangle B. Then I used that information to solve for my x. So there's a couple of steps that I go through here that I have to solve for. And all of these problems, even the 3D ones you'll see, will come down to 2 or more triangles that we can connect. I'll show you another example. I'll show you number 3. So for question 3, notice how we have 2 triangles here. I have the upper triangle that gives me the 45-degree angle here. I've got a side of 9, and I don't know anything else. And then there's this other triangle here that has x and a 45-degree angle here. So I need to solve for x, but again, I don't have enough information on this triangle that I'm highlighting here. So I need to figure out a shared side, and that's probably the easiest way to go for all these problems. So I see that triangle A and triangle B share this side right here, which I'll call the side length y. So step number 1, I'm going to try and solve for y. So I'm going to use the upper triangle first. So I'll separate it just to make it clear. I find it's helpful to sometimes draw it and break these problems apart this way. So I have this problem. So y in this case is my hypotenuse for triangle A, and 9 would be my adjacent side. So I'm looking at adjacent and hypotenuse. So I'm looking at cos. So cosine of 45 is equal to adjacent over hypotenuse. So I need to solve for y. When I see that y is in the denominator, the trick that I can use is to swap the position of the cosine 45 and the y. Technically, I'm dividing both sides by cosine of 45 and multiplying both sides by y, but our shortcut was to just swap the positions, so I can solve y is equal to 9 divided by the cosine of 45. And this gives me a value for y of 12.73. 12.73. So I now know this is 12.73. So the second triangle I have to solve for, if I keep it kind of similar looking, whoops, so I'm just moving it down here. I have 12.73, I have x, and I have 45 degrees. So notice again, the y that was originally my hypotenuse is no longer my hypotenuse. That in fact is taken up by x. The reason being is that we're looking at a different triangle, so that different sides will count. And then y, our 12.73, is our opposite now, because it's opposite of our 45 degrees. So I have opposite and hypotenuse. I'm going to be using sine of 45 is equal to 12.73 over x. Again, using my trick, I can swap positions and I get x is equal to 12.73 divided by sine of 45, and this gives me a final value of x is equal to 18. So again, going through these problems, I'm looking for two triangles that meet and working with them like this to try to find a shared side or a shared angle, and then going from there. The last one, I'll skip down to number 9 on this sheet. One of the things you'll notice is we actually have a triangle here. So if I, for a second, use a little bit of whiteout, I can clear up this and you'll notice that I actually have a triangle. So I'll get rid of that too. So I have 10 and then x. The problem with this is that I don't know whether or not this is a right angle triangle or not, so I don't want to just jump in and use this triangle. So one of the ways that we can get around it is I can split this triangle down from top to bottom, and notice what ends up happening when I draw this vertical line. I get a right angle here, and one of the things it leaves out is I get a right angle here, because I know that this side is going to be 90 and this side is going to be 90, because together they have to make 180 degrees. So I have my two right angle triangles. I'll just draw that in. Oops. So again, I'm looking for a shared side. I'm solving for x down here. And I have 10 and 60 here. I don't have enough information on this triangle, so I'm going to solve for the shared side that I've created. So I'm going to solve for y. So starting, I have opposite and I have adjacent. So I'll write edge, opposite. Again, this is my hypotenuse. So in this case, I'm using tan. So I have tan of 60 is equal to y over 10. So y could be solved as 10 times the tan of 60. And this gives me a value for y of 17.32. Next up, now that I have this value here, I'm going to look at the rightmost triangle. So now I have 60 degrees, I have x, and I have the 17.32 that I solved for. This is my right angle here. So again, I have opposite is x, adjacent is my 17.32. So again, I'm going to be using tan of 60. And now I have x over 17.32. So in this case, I'm solving x is equal to times tan of 60. So this is going to give me a final value of x is equal to 30. Keep in mind, it doesn't have to be tan both times. It could be tan and then sine, depending on how the triangles are arranged and which sides you're solving for. The important thing is that you're using the angles within each respective triangle and the sides that are respective to each triangle. So this is how we solve the two-part questions. Next class, I'll show you how to solve a three-part or a three-dimensional question using kind of the same method. As always, take care, stay safe, have a good one. Bye.